In this lesson, we're going to look at other properties of exponents. There's some other properties of exponents in addition to what you've learned before. Before we begin looking at those properties, let's remind ourselves what this expression means. So recall this expression. So if I had x to the fifth power, remember what that means. That means that whatever's being raised to the fifth power, this right here, remember that's called the base. And so what that means is that I'm taking this base and I'm multiplying it by itself 5 times. So I'm going to need 5 factors of x. So x times x times x times x times x. All right. So if I had this, let's say, x squared raised to the fifth, all right. So here's my base, right? So using that same idea, if this is the base right here, so this is the base x squared, then that means I would take this quantity x squared and multiply it by itself 5 times. All right, so I need 5 factors of x squared. Okay, now remember the product rule? So the product rule said that if I multiply like bases, I add those exponents. So 2 plus 2 plus 2 plus 2 plus 2 is 10. So this becomes x to the 10th power, right? So if you look at the exponent I have here, can you look at this and see how you can get x to the 10th using some operation? So what operation can I perform here to get x to the 10th rather than having to do all of this? All right, so think about that. How can you do this? All right, so if you said you could multiply, that's correct. So whenever you have a power raised to a power, see the exponent 2 and then the outer exponent 5, whenever you have a power raised to a power, you multiply. So 2 times 5 is 10. So you don't have to, and you really shouldn't, because this could be 500. You don't want to put this 500 times, right? So the rule is, or the operation at this point is that when you have a power raised to another power, or when you have an exponent raised to another exponent, you're going to multiply those exponents or multiply those powers. So this becomes, right here, this becomes x to the second times 5 to the 2 times 5, which is x to the 10th power. So that brings us to the power rule for exponents now. So let's consider the power rule for exponents. The power rule for exponents. So if you have some real number b, okay, and b is raised to the m power, but this quantity, this expression, is being raised to the n power, then I can simplify this by multiplying those powers, multiplying those exponents. So this becomes b to the m times n, just like that. Okay? All right, so let's look at some examples. So let's write this as examples. So in the examples, the directions will say simplify each expression. So simplify each expression. So we're going to use that power rule in this process. So let's look at that first example, number 1. If I have x to the 5th raised to the 7th power, then using the power rule for exponents, you have an exponent raised to an exponent, a power raised to a power, then I know that this is going to be x to the 5 times 7, right? 5 times 7. And so the answer is x to the, and then 5 times 7 is 35. So there's your answer. All right. So it's very simple. It is a very simple process. Number 2, you could have, let's say, 4 squared raised to the 3rd power, right? And so if you simplify this, simplifying basically means you, first of all, think about getting rid of the parentheses. So to get rid of the parentheses, you have a power raised to power. So 2 times 3 is 6. You get 4 to the 6th power. So there's your answer. And some of you may want to go ahead and use your calculator since those are numbers here. So 4 raised to the 6th power. Make sure you know how to use your calculator. Now that's the answer, but you can also indicate the answer as whatever that value is. So 4 raised to the 6th power is 4,096. Okay, so 4,096. But I would prefer you just leave it like this. Okay, number 3. Now let's think about number 3. based on what we've learned in a previous lesson. So if you had, let's say, x squared x to the fourth raised to the third power. Don't make that difficult. Think about what you've learned in previous lessons. If I were to cover up this outer exponent, you see what you have in parentheses? You have x squared x to the fourth. I want to try and make it look like this right here, where you have just one expression right here, just one variable raised to a power. You see, you have kind of two. I mean, they're the same variables, and I kind of gave it away, but they're the same variables, but it's two different factors you can think of: x squared times x to the fourth. So if I were to cover this part up, you learned something in a previous lesson. When you multiply like bases, what do you do those exponents? You add them up, right? So that's the product rule for exponents. So when you multiply like bases, you add exponents. So x to the second power, or x squared, times x to the fourth power is x to what power? The sixth. And so the best way to do that one is to simplify what's inside the parentheses first. You get x to the sixth, and then raise it to the third power. All right? And so 6 times 3 gives you x to the 18th power. And there's your answer. All right? That's all you do. It's not a very difficult concept, right? Pretty easy. Okay? All right? Now, let's look at this idea. All right, let's consider the following expression. What if I had this, this expression here? xy raised to the fourth power. xy raised to the fourth power. So based on what we've learned in a previous lesson, and also in this lesson up to this point, my exponent's 4, right? So that means that if I consider this my base, xy, that means I would take xy and multiply it by itself 4 times. Y'all agree? That's what that means. Okay? We also know from a previous lesson that we can put all the factors of x together and all the factors of y together. So meaning that I can say x times this x times this x, these are multiplication here, times this factor of x. So I have 4 factors of x, right? 1, 2, 3, 4. And then I can do the same thing with the y's. Y times y times y times y. Correct? And so if I look at this using the product rule for exponents, when I multiply like bases, I add those exponents. So 1 plus 1 plus 1 plus 1 is x to the fourth here. And then over here, that will be y to the fourth as well. All agree? Okay. Now, consider this and the answer right here. If you look at this, rather than doing all of this that you see here, rather than doing all of this, there's another way, a much easier way to go from here to the answer, and that's this. Notice that I have 2 distinct factors, 2 different factors that are in my base. One's an x, one's a y, right? One factor's an x and another factor's a y in that base. Each of those factors are being raised to that fourth power. That's what it says, right? So x raised to the fourth, and then y raised to the fourth. So what that means is this. Instead of doing all of this, I can say x to the fourth times y to the fourth. So take this factor that's in my base, raise it to the fourth, and take this factor in my base and raise it to that outer exponent 4 as well. So then I get, remember that this is understood to be a 1, right? That's understood to be 1. So 1 times 4 is 4, and then 1 times 4 is 4, and you get your answer real quick, just like that. I can also, and we'll come back and do some problems similar to this, so it'll become a little bit easier to understand. So you could do the same thing with a product, with a quotient instead. X divided by y raised to the fourth power. So rather than just saying a product, this idea here applies to quotients. Remember quotient division, quotients as well. So I have, if I use that same approach here, the base here is x divided by y, and I'm multiplying it by itself 4 times. So x divided by y times x divided by y times x divided by y times x divided by y. Correct? That's what that means. And if I look at all of the numerators are factors of x. So I can write that as this. x times x times x times x. The denominators, these are all factors of y's. So y times y times y times y. And notice that in the numerator, when I multiply like bases at exponents, so x times 4 factors of x times x times x times x is x to the 4th. That's a 4. And then for y, the same thing, y to the 4th. If you look at this, to go from here to this answer here, this answer, what do you think you're doing to this base here? So if you think about it, you're taking the numerator, the factor that's in the numerator, raising it to that exponent, right? So basically you're saying x to the 4th divided by y to the 4th. So what is it? Whatever's in the numerator, you're raising to the 4th. Notice I put the numerator in parentheses. And whatever's in the denominator, I'm putting the denominator in parentheses, and you're raising to the 4th. And we know that x to the 4th is x to the 4th. Y to the 4th is y to the 4th. Okay? So rather than doing all this, whenever you have a quotient raised to the outer exponent, then take the numerator, raise it at power, take the denominator, raise it at power. Okay? And so these have names. And so here are the names for these properties. So the first one's going to be called the power of a product rule. Power of a product rule. So the power of a product rule is this. If you have two real numbers, a times b, okay, and it's raised to the m power, based on what we saw here, all I need to do is just take each of those factors that's in my base and raise it at power. So basically you're saying you're going to take whatever this factor is, you're going to raise it to that power, and whatever this factor is, you're going to raise it at power as well. And then the other one would be called the quotient. Let me write it this way. Power of a quotient rule. Power of a quotient rule. And so instead of a product, you have a quotient. So it'll look like this. A divided by B raised to the m power. So what that power of a quotient rule says, I can simplify this expression by taking the numerator and raising it to that exponent, and taking the denominator and raising it to that exponent. Okay? Now, just remember, whenever you have a fraction, your denominator cannot be 0. So usually you'll see people say that when you have a power quotient, you just got to make sure that b does not equal 0, because that's undefined. You cannot divide by 0. All right. So we're going to go ahead and do some examples using those properties. So let's look at this example. All right, we're going to start out with a simple one. So let's suppose I had x to the 3rd power, y to the 2nd, raised to the 5th. So x to the 3rd, y to the 2nd, raised to the 5th. So according to the power of a product, see, you have a product here, x cubed times y squared. Whenever you have a power of a product, then I can rewrite this as each of those variable expressions raised to the 5th power. So it'll be x cubed raised to the 5th times y squared raised to the 5th. So I'm just using the power of a product rule. So you take each of those factors that's in your base and you're going to raise it to the outer exponent. So in my base, I have x cubed that's being raised to the 5th, and I have y squared being raised to the 5th. Okay, that's what you see here. And now I'm going to use the power rule. So the power rule. So 5 times 3 is 15. So this becomes x to the 15th power. And then 2 times 5 is 10, y to the 10th. And there's your answer. Okay? And we tend to put them in alphabetical order. So notice x, y. If you wrote it as y to the 10th, x to the 15th, that's fine as well. But you'll see it written usually in alphabet. This will usually be in alphabetical order, and this will be in alphabetical order. But that's not always the case, but most times it will be. All right, let's get this example. So in this example, let's suppose we had, um, let's say we had 4x to the 5th power, y to the 7th power, all raised to, let's say, the 3rd power. Okay? Now, these two look similar only in the fact that you see x's and y's being raised to an outer exponent. The difference is that here you actually see a number for your coefficient. Now, there's one here. It's understood to be a 1, but we didn't say anything about it. But here that's a 4. So some students have difficulty when they see a coefficient there. They can do this and get the answer for this one without any difficulty, but sometimes they have difficulty with this one, and because of that number here. Just remember what the power of a product rule says. The power of a product. Always look at your base. This is your base. So your base, there are three things here. There's a 4, an x to the 5th, and a y to the 7th. So if you need to underline each of those, you do so. And so I have 3 factors in my base. So I have 1 factor of 4, and I have 5 factors of x and 7 factors of y. But I consider these as 3 items here. And so I've got to raise 4 to the 3rd power, just like this. And I've got to raise x to the 5th to the 3rd power. And I have to raise y to the 7th to the 3rd power, just like that. And now I can use the power rule. So this is 4 to the 3rd. Okay. This is x to the 5 times 3 is 15, so x to the 15th. And then 7 times 3 is 21, y to the 21st. Now, you need to take your calculator out because you can't leave this as it is right here because we can easily find what 4 to the 3rd power is. So use your calculator. So 4 to the 3rd, 4 raised to the 3rd here, 4 raised to the 3rd is 64. So you get 64, x to the 15th, y to the 21st. And there's your answer. Okay? Now, always, in your answer, always put the coefficient in front. So make sure that the coefficient of this expression is in front. So 64 is in front. Okay? All right, let's look at another one. Let's suppose we had, let's say, a negative 3x y squared z. And all that's being raised to the, let's say, 6th power. Okay? All right. So I have this base here that's being raised to the 6th power. Okay? And so if I look at my base here, I have a negative 3, I'm underlining it, times an x, times a y squared, times a z. So I have 4 things underlined. Each of those things, those factors, are going to be raised to the 6th power. So in your mind, you have this. You have negative 3 to the 6th power, x to the 6th power, y squared to the 6th power, and then z to the 6th power, just like that. Okay? Now, for this one, I'm going to leave, now be careful, see this is negative, right? So you have to be careful. So I'm going to rewrite this over and I'll come back to it in a little while. So negative 3 to the 6th power, let's leave that alone for right now. Now this exponent right here is a 1, right? And so I can use the power rule. 1 times 6 is 6, so this is x to the 6th. The exponent here is 2. 2 times 6 is 3. I'm sorry, 2 times 6 is 12. So y to the 12th. And then again, this implied exponent here is 1. 1 times 6 is 6. All right, let's talk about this. This is negative 3 to the 6th power. So in your calculator, remember we talked about this in a previous lesson, a negative number raised to an even power better be positive. So on your calculator, go ahead and you have to actually find this. You can't leave it like this. So in parentheses, you're going to say negative 3, close the parentheses, all right, and then raise it to the, in this case, 6th power, just like this, and you get 729. So the answer will be 729, x to the 6th, y to the 12th, z to the 6th. Notice the coefficients in front, and these are in alphabetical order. They don't have to be in alphabetical order, but that's how we tend to write it. Okay, let's look at number 4. So number 4, we have 1 divided by 5x y to the 6, and all that's being raised to the third power. All right, so now I have a quotient, right? I have a power of a quotient. Power of a quotient. Here, that was a power of a product. So power of a quotient, remember how we talked about that? Power of a quotient, you're going to take the numerator, raise it at power, take the denominator, raise it at power. Okay? So in other words, do this. Write it like this so you don't get the wrong answer. So I'm going to take the numerator, which is 1, I'm going to raise it to the third power. Then I'm going to take the denominator, which is 5x y to the 6, and I'm going to also raise it to the third power. So numerator to the third power, denominator to the third power. That's what you see here. Okay? This one's easy. 1 raised to the third power is 1. 1 raised to any exponent is 1. Now, in the denominator, let's think about the denominator. So let's go here and think about that denominator. So in my denominator, I have this, right? So let's think about this. Y to the 6 raised to the third. So in the denominator, to simplify this denominator, I'm going to have to use the power of a product in this case. So notice in number 4, there were 2 properties you used. You used power of a quotient, and then to simplify this, I'm going to have to use power of a product. And so using a power of a product, this means 5 to the third power, right? Times x to the third power, times y to the 6 to the third power. So each one of those factors being raised to the third power. Using your calculator, 5 to the third power, if you use your calculator, that's 125. And I forgot to put this x in parentheses, sorry. So that's x to the third. So x, and remember that's a 1 here, so x to the first raised to the third, 1 times 3 is 3, so that's x cubed. And then 6 times 3 using the power of a power. The power rule, 6 times 3 is 18, y to the 18th power. All right? And that's the denominator. So my denominator is 125, x to the third, y to the 18th. Just make sure you extend it, and it looks like this. There's your answer. All right. So in some of these problems, you have to use multiple properties, multiple rules to get to this answer. All right. So that was number 4. Okay. Let's look at number 5. Okay. So number 5. Let's suppose we had this one. So notice I want to simplify this expression. So I've got to use all the properties I've learned so far. Notice I have a power of a quotient. Power of a quotient. So let's go ahead and use that rule. So the power of a quotient says I take the numerator, raise it to that exponent. So I'm going to write it like this. 3x cubed y, all raised to the third power. And I'm going to take the denominator and raise it to that exponent. So z squared raised to the third, just like this. Okay? All right, now, so I use the power of a quotient to get it to this point. So remember, I just did this one. I use the power of a quotient. Okay. Now to simplify these further, I'm going to have to use the power of a product. Okay. So the power of a product says I take each of these factors here and I raise it to the third power. And so I get 3 cubed times x cubed, right? Times y cubed. Okay. This to the third, this to the third, this to the third. That's what you see. And I'm going to just go ahead and leave this alone for right now. Okay, so to go from here to here, I use the power of a product. Okay, right here, at least in the numerator. So I use the power of a product. Now what I'm going to do is use the power rule. Well, first of all, 3 to the third power is 3 times 3 times 3, right? So that's 3 times 3 is 9, 9 times 3 is 27. So basically you're going to say 3 raised to the third power is 27. So that's 27. X cubed raised to the third power, using the power rule, 3 times 3 is 9, right? So that's x to the 9th power. And over here, that's under this exponent inside the parentheses here is understood to be a 1, implied 1. 1 times 3 is 3. That's y cubed divided by, and then using the power rule here, 2 times 3 is 6. So z to the 6. And that's it. There's your answer. So go from here to here, I had to use the power rule. Okay, power rule. Okay, so notice all different kinds of properties you're using in each of those cases. Okay, all right, let's look at one more, and I think you should be good. Let's look at one more. All right, so this is number 6. So you're seeing a lot here, but as long as you understood all the others, understood those properties, this should not be any different. Okay, so if you need to cover up some things first, make sure you do that. So for example, let's look at this right here. So I have a power of a expression, right? So I can use a power rule. So 6 times 3 is 18. So right away I know that this is x to the 18th power. So go ahead and write that, x to the 18th. Simplify that. And I kind of, okay, and then here, that's a 1 up here, right? So students get confused. They're like, well, there's no exponent there. Yeah, there is. There's an exponent. It's understood to be a 1. So 4 times 1 is 4. So that's just times x to the 4th, just like this. Don't make it difficult. And then here I can use the power rule again. 2 times 5 is 10, so you get x to the 10th. All right? Now, look at the numerator. Cover that denominator up. In the numerator, I can use the product rule for exponents. When you multiply like bases, you add exponents. 18 plus 4 is 22. So it becomes x to the 22nd power divided by x to the 10th. All right, so that's where we're at. Okay? Now, look at this situation. You have like bases, right? So you have that factors of x in the numerator, and you have factors of x in the denominator. So you can simplify that further. So remember the quotient rule? So the quotient rule says when you divide like bases, you subtract exponents. So this is going to be x to the 22nd minus 10, which is x to the 12th power. Very simple, right? So notice to go from here to here, I use the power rule. Okay, so I use the power rule. And then to go from here to here, all I did was use the product rule for exponents. Product rule for exponents, right? And then go from here to here, quotient rule for exponents. Quotient rule for exponents. Okay? So notice it's not that difficult. It's just utilizing all those properties you've learned to simplify this expression to this. So this expression is simplified to this. So that's the simplest you can write it. This right here is the simplest you can write it. Okay? All right, so let's look at number 7. So it's not difficult. Just think about what you're dealing with. So in number 7, let's suppose we had 4ab to the 3rd power times, let's say 3ab squared, all raised to the, let's say, 2nd power. Okay? All right, so you want to simplify this. So think about what you have. Think about what you have. And I'm going to say this. A mistake students are going to make right away is they want to say 4 times 3 is 12. You got to be careful. All right, you have to be careful. Don't say 4 times 3 is 12, because this is not a, if you look at this, it's not a 3 to the 1st power. This is 3 to the 2nd, right? So you got to think about what you have. Always look at your expression as a whole. So I have 2 sets of parentheses. So this parentheses here is being raised to the 1st power, correct? But this parentheses here, this quantity here, is being raised to the 2nd power. So I've got to deal with that first. I have to think about what is the power of this product right here. So what I got to do first is simplify this. All right, so let's go off to the side and kind of do that. So 3ab squared raised to the 2nd power, that simplified will be 3 squared. So remember, power of each of those. So you're taking each of those factors here and you're squaring it. That's a 2 right here. And so you get 3 squared times a squared times b squared squared, right? Well, 3 squared is 9. And then a to the first raised to the second is a, that's a 9, is a squared. And then 2 times 2 is b to the fourth. So that goes here. All right. Now, notice 4ab cubed raised to the first is itself. So I can write this as 4ab cubed times 9a squared b to the fourth, right? And now I can say 4 times 9 is 36. A to the first times a to the second, using the product rule. So when I multiply like bases, I add exponents. This exponent is understood to be a 1. A times a squared is a to the third. And then b cubed times b to the fourth is b to the seventh. And there's your answer. Okay? So it's just you being able to use all the different properties that you've learned. We're going to do one more just to kind of finish this off. Okay, so let's look at this one. So I have this expression, you don't freak out. It's easy to deal with. Think about your properties. So what I would do is I would cover up, let's say, the denominator and look at what you have in the numerator. So you have 2 sets of parentheses in the numerator, right? So if you cover up this part even more, let's say, right here, then I know that the property I'm going to use here will be the power of a product, okay? And then I can do the same thing here. Think about this right here. So this parentheses, I'm going to be using the power of this. Now this is not a product. Well, technically it is. B to the fourth means b times b times b times b. But basically you're going to use the power rule. When you have a power raised to power, you multiply, right? So that'll be the power rule. So basically what I would do here is I would think about this part here as this. Negative 8 to the second power, right? And then b to the fifth to the second power. So b to the fifth to the second power. And then here I have b to the fourth to the fifth power. Okay? And then the denominator, that's just 4b. So just rewrite it over. That's a simple one. You just have 4b in the denominator. Now let's simplify the numerator. Negative 8 to the second power means negative 8 times negative 8, which is a positive 64. So if you're using your calculator, you have to make sure that this negative 8 is inside parentheses, because if it's not, and you do it like this, without parentheses, without the parentheses, you're going to get a negative 64, and that's wrong. Negative 8 times negative 8 is a positive 64, so be careful. And then here I'm going to use the power rule. 5 times 2 is 10, so that's b to the 10th. And then b to the fourth to the fifth, use a power rule. That's 4 times 5 is 20, so b to the 20th, all divided by 4b. Okay? Now, I can simplify the numerator further, couldn't I? Because I can use the product rule. When you multiply like bases, you add exponents. 10 plus 20 is 30. So this becomes 64, b to the 30th, divided by 4b. Okay? Now, you need to ask yourself, can I simplify this further? Yeah, you can. I can simplify the coefficients here, and I can also simplify these factors because I can use the quotient rule. Divide like bases, you subtract exponents. So I'm going to rewrite this as 64 divided by 4 times b to the 30th divided by b. All right? And so 64 divided by 4, that's a nice number. 64 is divisible by 4, so that's 16. And then here, be careful, if you don't see an exponent, that's that implied 1. So this is b to the 30th minus 1. And so your answer is 16 times b to the 29th power. Okay? And that's just you using those properties that we talked about. And so that is now there's some other properties, but so far you've learned some more properties. So you've learned about the power rule for exponents, and you learned about the power of a product rule and a power of a quotient rule. So you learned 3 new properties for exponents. So you learned 2 last lesson and you learned 3 in this one. So there's some others, but we're getting to the point where you're going to be able to simplify any expression given to you. All right, so that's going to be the end of this lesson.